Hello! I'm Rachel, and I'm going to clone a classic arcade game. And we're going to start from start to finish, and this is not actually the game, but I wanted to show you what we'd be using today. So, my plan is every time we'll use a different tool / language, and we'll clone some classic game without copyright infringement. Yep, so this is a thing that I've just worked on in Greenfoot, where you can just kind of set up a little tiled map, and that was just an example of saving and loading stuff in Java. So what we're actually going to do is make a, you know what? I need to set up a GitHub for this, so let's go ahead and do that. Let me open up GitHub, and I'll need to log in. And let's go ahead and, I don't know if I should make an organization for this or something else. Can we do that from here? Create new organization. I forgot to do this ahead of time, so we'll just do that now. We'll call it classic clones, and okay, it has to be classic clones like that. We're going to make it open source so I don't have to pay anything. And create organization. And there's a problem. Okay, whatever. Rachel. I'm not going to pay for it. But okay, so this will be me. Well, I don't know if I need to. Okay, I already added myself. Continue. We'll go ahead and we're just going to do this as an educational program. And, I don't know, maybe a few weeks to months, maybe a year or more. It depends. And how many people, I plan to work alone, or you all can fork the repository and make your own. So, we've made a repository. I'll have to update this picture later to make it more attractive, but let's create a new repository. We'll call it Moose Invaders, and we will go ahead and make this MIT. We're going to be using Java, so I'll set up a gitignore for Java. We might have to add some more stuff because we're using Greenfoot as well, and I'll probably want to add some of the files we don't need. So, okay, clone, and now I need to put a location on my computer to store it, so let's go ahead and we'll do just a classic clones folder. Oh, where'd my thing go? Classic clones, and we'll make a clone of this repository. So git clone paste, and then it will basically, GitHub has auto-generated the license and README for me. So now I have a place where I can store my project files. And when I make commits, it will be up here, open source, everyone can see the source code. And in the meantime, I need to make a Moose Invaders Greenfoot project, so let's just name it that. Copy this path, paste it in here. This is where our new project is. And in a moment, the new Greenfoot has popped up. And here it is. It's probably going to change this so that the screen is a little bigger. I also like to erase these comments because I don't like these comments. They're always just so cluttery. But we can set this to 600 by 600 for now. And, well, there are different things. Greenfoot comes with some images automatically, but we'll probably make our own. Here's some space background. But I was planning on also doing the graphics and then also doing the coding. So we can kind of go through the entire process of making a simple game. With Greenfoot, it's pretty easy. As you can see, there's a world class and an actor class. So a lot of the stuff is already taken care of, whereas with like C++ and SDL, I'd have to end up doing a lot more work. So I'm not going to plug in my tablet right now. We're just going to make some rough art and try to make it look good. Since I'm not plugging in the tablet, we'll just do some pixel art. So here's the background. It's kind of spacey. There we go. Save. Okay. And now I'll put it in this images folder from Greenfoot. We'll just name this. Let's overwrite this space image just because. And let's see, reset. Okay, that did not overwrite it. Will you click that? Okay. Now we have a background. Yay! Okay, So in a Space Invaders game, we'll need some Space Invaders. So let me create a new image. I don't know. I drew a Space Invader earlier, but let's go ahead and look at Space Invaders, just images of them. So here's a nice picture of what kind of stuff we have for reference. I'm not going to copy it exactly. Let's go ahead and just start with really low resolution sprites. We'll do 16 by 16. I'll set my pixel size to that, and I'll make a new layer. So Moose Invaders, we need different mooses. I'm going to set this here. Yay, pixel art. I actually don't like doing a whole lot of pixel art, but it is easy to do, and it is easier to animate. So we'll just go with this for now. We're making classic style arcade games, and back in the day, you almost never saw hand-drawn art. Sometimes you would, it'd be a special gimmick, but it just wasn't as common. So let's go ahead and add little feet to the Moose Invader. We need to give it some ears, cute moose ears. So here's our first Moose Invader, and we can just start off with this. I'm not sure how this is going to look against this background. I might go ahead and make a copy of this layer, and then something I do is I'll usually make this copy all black. I'll put it on this layer, select the move tool, copy, paste. I hit the up arrow key to move it up one, and I just basically make several copies and do that to easily make a nice black border. We can also crop to the layer size. We'll do auto crop image, and it will do that. If you want to, it's up to you. So I'm going to, I don't have the path saved anymore in my copy buffer, so export here to, we'll call this a invader1.ping. I'll go ahead and save just this invaders. So you'll be able to get the XCF file as well. And then in here, we can create a new subclass. Now, we are going to have a player and a invader, and both of these will have shared properties, such as being able to move. So let's just create a movable object, and then from there, we'll create our, oops, that's not what I want. Create a new subclass, we'll do an invader. Now the invaders, we don't have to make a different invader for every look. So I can, for example, put this in here and it's tiny. We might want to make that image bigger. We can make it just bigger pixel art. I'm going to set it to none, and we're going to scale this by 4. And I'm going to re-export it, and it should just update automatically, I think. So if I create a new invader, there we go, much bigger. So as I was saying, I forgot. Oh well, let's just work in the movable character thingy for a moment. So, at the moment there are no invaders on the screen. In Greenfoot we can just add a new invader that way. The way the program works is we can hit run, and it will run every actor, and the world has an act method, and that's automatically called every cycle. So Greenfoot is generally pretty nice if you want to like make a quick prototype of something, but in the world we'll end up creating more invaders. We'll just do one at a time at the moment while we're doing this. So we can do something like public void move left, and we can just create a bunch of moving functions that the child classes will use. So public void move up, public void move down, and you can either do this the long way and say like, okay, int x, y, x is get x, which is the function that belongs to the actor class to get the x coordinate, and we can say int y equals get the y position, and let's go ahead and create a protected int speed. So since it's a protected class member, any of the child members will also get their own version of this speed. So we could do something like this. If we're moving left, we're going to subtract by the speed, and then we can use set location to change the sprite's location. So let me go ahead and create a new invader. If we say At the moment it has no speed, so let's just set a default public movable object. Speed is 5 by default. We should then be able to say create a new invader, right click, inherited from movable object, and I've created an act. It's been redefined, but it's not really full of anything. We have move left, and so we can use this. So we can kind of just manually test things here and then eventually end up building the full game. So this is the long way to do it. I'm going to do this instead. Set location. We're going to get X, and we're going to subtract it by the speed, and get Y. This basically does the exact same thing as down here. It's just one line long instead, and it's still relatively clean and easy to read, so that's the one I prefer. Now here for Y, going upwards is going to be subtracting, and then going downwards is going to be adding, so we have our move methods. Now with the invader, I'll open this one up. We will open the public invader constructor. We'll set its speed to maybe 2, and we can adjust that as the game goes on. And let's say for now, every time the program cycles, we'll just say move right. So I'm going to add a new invader, and we can test it just by saying run, or we can do it cycle by hitting act. And you can adjust the speed of the game. Now, in Greenfoot, it doesn't let the characters go off of the side of the screen. So that could be a problem if that's something you wanted to program, like maybe a screen scrolling shooter or something like that. But it is also nice because then you don't have to do all the checks for the boundaries of the screen. There are other methods, such as, let's go to documentation and see if it shows us the, I don't need the invader one, I kind of wanted the actor one, but it'll show us the methods inherited from the Greenfoot actor class. So we have stuff from like, is it added to the world? Get image, we can modify its image, like scale it and stuff. Is at edge, is at the edge of the screen. We can check to see if it's intersecting with something, so we'll use that a little later. We don't have to necessarily write our own collision detection, it will handle that for us. So now that we have an invader, let's go ahead and just start adding these to the world. I'll go ahead and create a array of invaders, so invader, an array, and we can do something like just invaders. Now, usually when I'm programming, I like to make my private members have the M underscore. That's just my style of things, and normally I like these to be capital, but that's more of like, I think, C++ style than Java style. But we'll have this private M invaders class. In the constructor, we will initialize it. It's a new invader class, and I don't know how big to make it. Let's just make it 5 for now, and we'll adjust it as we go. So let's say public void setup invaders, and we can use this to kind of set their locations. We could just put in the constructor, but this will make it a little bit cleaner. So eventually I'm going to want a row and several columns of these invaders. So let's create a for loop. Int y is 0, y is less than, okay, so y coordinate will be the vertical, and then x will be the horizontal. So let's say we want 3 rows, and I'm not sure how many wide we want the x. We'll see what that looks like. So here we'll actually end up wanting 15 invaders if we're going to do 5, I guess, columns and 3 rows. So let's make this 15 instead. Now another thing we have to do is we're going to have to initialize each invader element, and we can do that here, or we can do that down here. So let's go ahead and say int index is 0. Since these are keeping track of x and y coordinates, we'll need to keep track of the individual, well, let me think. Let's just go ahead and initialize these properly here. I is 0, I is less than minvaders.length, I++. So we have to say minvaders at this position is a new invader, and that will call the invader constructor, which doesn't really do anything at the moment, except I think maybe sets the speed. And then down here we can actually set the characters. So anytime I hit reset, the world constructor is going to be run, but at the moment we're not calling the add object method, which belongs to the world, and we'll put it on the screen for us. So we're creating them, but we haven't put them on there. Down here we can say add object. We can add a specific object, and again we need to keep track of the index. So index, and we can give it an x and y coordinate, which I'll fill in a moment, and index plus plus. So there's a whole bunch of these up here now. So instead we can do x and y, but we need to adjust for whatever the width and height of the characters are. So int. We can either do this programmatically or we can hard code it. So let's say the width is equal to, and let's just go with invader 0 dot get image, and I think dot get width. We'll see if that compiles. Okay, that compiles. And height is get image dot get height. So we have width and height. We can say x times width, y times height, and that should space them out a little better. But now they're all kind of in the corner, so we also have to add an offset. And if we want them to be spaced out more than just the exact width and exact height, we're going to have to adjust this as well. So let's say whatever their width is plus 10, whatever their height is plus 10, we want a little bit more space between them, and we want them to be offset with, so we don't want them to start like that. So I don't know, let's do plus 64 and plus 64. So I'm just kind of hard coding that in, but that gives us that. We can see that, you know, maybe we want another 2 or 3 columns. So let's change this to 8. 3 times 8 is 24. And okay, that's not quite what I want. Let's make this 7 instead. So we'll do 21. Okay, so we have a nice array of our invaders. If I run it, they all just kind of gather up at the edge of the screen. So let's fix this. Movable object, again, no, we want the invader code. So we can, it'll move right. How do we want to do this? For now, let's just go one step at a time. If is at edge, which is one of the actor methods, we can tell it to move downwards a little bit and then change which direction you're moving. So let's just create a boolean. Boolean is moving right, and we'll initialize this to true. We'll say if is moving right, we'll move right, otherwise they will move to the left, else move left. I don't really like writing code this way. I really prefer to have my curly braces surrounding it, because I could always come back and modify this later, and then I'd have to add them anyway. Okay, so now, I mean, they'll still have the same behavior, but if they hit the edge, we want to make sure that they turn around. So we'll say is moving right is equal to the opposite of is moving right. So if it's currently true, it's going right, then I'll switch it to say false. If it's going left, so is moving right is false, then we'll switch it to true. So let's see. That gets us to go back and forth, but we also want them to move downwards a little bit whenever they do that. So let's get the int x is get x, int y is get y, but we want to subtract the y coordinate from whatever the height of the character is, or maybe some preset. So let's say get height, we have to do get image dot get height, and that should have it go downwards. That did not. Because I forgot to say set location, x and y. So now it should do that. Oh, that was the wrong direction. We need to add that. Oops. Run. Okay. Now, what does it look like in actual Space Invaders when we are, when they are going downwards? It's, maybe they're spaced out more. Or no, all of the invaders like kind of move the entire row down, don't they? Wheel. I don't know. Let's play with these numbers a little bit. we don't have to make it exactly like the original. Nah, I think I'm just going to change the spacing on those a little bit. So let's say height times 2, so that they're spaced out by the row, and then they're just going to go down by their height. So maybe that'll look a little bit cleaner. So that looks better to me. So we'll keep the invaders going downwards like that, and we can add our player next, or we could animate these. You know what, since we already have GIMP open, this guy's been blown up, so I'm going to shrink it back down. Let's make the second frame. So we'll use this dude as a reference, and I'm going to put him in his own layer group, and we're going to make another layer group and just start working on the next version. So pretty much the same looking, but maybe with the little, well, I guess that's supposed to be ears, but maybe they're moose hands. Who cares? Okay, so we'll have it be mostly the same, but it'll be like meh, meh, instead, and maybe move its leg out. So let me copy the hoof color and the antler color, and the antlers will be the same. And okay, so we can clear that. I'll do my same copy and change black trick. Do move, copy, up, down, left, right. So this is our second frame. We'll name this Invader 1 B. Okay, so now if we want to change the character, we're not going to probably want to change it every single time that it moves, because that would be really fast. But let's see what it looks like. Set image. At the moment we don't have multiple invaders, but we can say Invader 1B, and I forgot to resize it so it's gigantic, so let's do that real quick. Times 4. We'll change it to Invader 1B.ping. Let's see. We want to be able to set it back and forth. Let's say string frames and int current frame. We can set current frame to 0. Frames is a new string array of size 2, and we'll just set frames 0 is invader.ping, and frames 1 is invader.b.ping. I think, was this invader 1? No. Okay, and since these are going to be private anyway, let's go ahead and put the m underscore just to kind of keep things consistent. Special guest appearance from Kat. Hey Kabe, what's up? How are you doing? You want to sit on? You don't. She's not much of a lap cat. I don't know why she's right here right now, because she doesn't normally like to sit on laps. But today she is. This is a first. Okay, and then we'll fix these. All right. So we have a frame. I might actually change this a little bit. The trick I usually do is I set this as a double, or in C++ I set it as a float, and I just increment it by a small amount each time. So let's maybe make a method, since this is kind of, if we keep adding to it, it'll get big. So let's say public void update animation, and down here we'll say update animation. What we'll do is we'll add maybe 0.1 to the frame each time. This will allow us to adjust the speed of the animation. And then basically we will set the frame to whatever this is, frame 0, frame 1. So set image, and we need the name of m frames, and then we can use m current frame, but because this is a double, we'll cast this to an integer, and by doing that it gets rid of, okay, how do we, I don't care if there's conversion stuff, that's what I want you to do, that's on purpose. Okay. How do I have to like do a special function to get Java to convert to, okay, bye cat. Java double to int, because yes, that's literally what I want. Yeah, I know. D.int value, okay. .int value, let's see if that works. Why does that not work in current frame? Okay, wait a minute, this is this here. Now what? Double cannot be deref. Okay, so C++ is kind of my primary language, so sometimes I get confused by Java errors. Okay, so as I was saying, when you change a double or a float into an integer, it's going to get rid of the period remainder bit, and from there you can use that to say, okay, array index 0, array index 1, but then we also want to say if m current frame is 2.0, because we don't want it to go over the array size, we'll just set it back to 0. 0.0. Compile, let's see if this works. I have update animation called. We're incrementing the frame. There we go. So they're moving maybe their arms a little fast, so then we can say plus 0.01, then they'll move really slow. So you can see they very, very slowly change. Or we can say 0.5 if 0.1 was okay, but still too fast. So we can do something like that. We can adjust, excuse me, adjust the speed with this float. Okay, so we have these dudes animated. We need our player character next, and we also need to have a state that happens for when these dudes get all the way down here, or maybe if they touch the other player. So let's go ahead and, in Space Invaders it just looks like a really cruddy ship, but what should we have? What should we have as a thing? Well, you know what? I'm getting hungry, so I'm gonna get lunch, and then we'll do this, because maybe I need some extra brain power right now. Be right back. So for lunch today, I'm going to have some green tea and some aloo tomatar curry that my boyfriend made last night. Now, aloo tomatar just literally translates to potato tomato, so that's your Hindi lesson for today. When you're going to create your new RPG characters, remember to name them Aloo, because that's a pretty cool sounding word. Alright, I'm back from food. So, I'm not really good at drawing mechanical things, so we're just going to say that we're going to be protecting the world from evil moose with a awesome kitty cat. So let's just make a rough kitty cat shape. I guess that's identifiable as a kitty cat. Maybe move that over. It's not like an even number of pixels, so it's not perfectly centered, but we'll do that. And we'll save this as cat. And let's see, let's do cute little scarf or something. Yeah, I don't know, I just felt like giving the cat a scarf. And cats are usually naked besides scarves, so we'll just do that. This will be the cat. Maybe move its head over a little bit. And I don't know, how do we indicate that the cat has a gun or something? I don't know. We'll just do cat gun thing, maybe? I don't know. We'll just have to take it for granted. This cat has a gun, so I'm gonna do my little trick again. And we have to make sure it's blown up, so get rid of that layer. We will scale ×4, and we can also do the auto crop image so that fits that size, and we'll just name this cat. It is hot in here, but I don't want to turn on the fan because that would make noise. So, new subclass, cat. We'll just name this player. Okay, Let me move my coffee over here so I can type a little better. Move this over here. Bunch of wires everywhere. We really need wireless everything. Okay, so we have a player. Let's go ahead and go to my world. We'll create a new player object. So private player. Only going to have one player. Down here, let's do is a new player, and we're going to add it to the screen. So add object player. We can, everything in Greenfoot is based on the center point. The XY coordinates are based on the center point of an object. So if I say get width of the world divided by 2, that's going to just automatically center it for us. So that's kind of nice. And let's say get height minus 100. Let's try that. Okay, so let's make it 64. So now we have the kitty cat, and we can go in and start adding code to this. So for the cat, it will be controlled through the keyboard input. So let's just go ahead and say public void check input act, we'll call that. And we also need to make sure to initialize the speed of the player here. So let's see. Those guys go pretty fast, so maybe we even want to set the invaders. Oh, it's already at 2, so the player will move really fast. Maybe we'll set this at 2, and we'll set the invader at 1, just to make it easy on us. And we'll check input. So Greenfoot has if greenfoot.is key down, and you just pass in the string. So we can do up, and we'll say move up, which is a method in the movable object. And we can basically just keep doing this. Of course, we aren't going to be moving up and down. We'll just do left and right. So move left, move right. So now I can move my character. It feels so slow. It needs to be a little faster. Set it to 3. Try that out. Run. Whee! Okay, that's alright. And we'll probably also want to listen for the button for if you're shooting. So let's go ahead and listen for the space bar, and I think it's just space, not 100% sure. And let's make another method like public void shoot. So that way we can kind of extract that code into its own method. So I don't know whether spacebar is correct or not, so let's just say get world dot show text shoot, and we'll say, I don't know, 200 and 200. It's just a test. So do that, space, that text shows up, so good. We'll actually probably want that for the score later on, but not right now. Remind me to put a score in, because otherwise I'm going to forget. Let's put it on some paper. Score. And my hair looks dumb. There we go. So, we'll probably need a bullet object. The bullet object will also be a movable object, and so it'll share that stuff in common. Let's go ahead and, where's GIMP? There it is. We'll make maybe an 8x8 bullet, and the background is purple, so let's just make this maybe we'll make this a little bit bigger. We'll increase the canvas size by 1 pixel. There, so we'll have just a yellow bullet, and we can copy this and give it an outline as well. Maybe we want it to be a red outline instead of black, so it's a little bit more visible. Let's just do that. It's not a very attractive bullet, but it will work. So, bullet. We'll name this bullet. We will also need to blow it up as well, because everything else has been blown up by 4. Do that. We'll say a new subclass. We'll just name it bullet. It is this bullet. If we create a new one, oh, I forgot to do the background thing. I forgot to get rid of that. Also, it's kind of big, so let's just make it double the size instead of quadruple the size. So, reset, create a new bullet. There we go. So that's a better kind of size between them. Alright, so void shoot. Maybe the world should handle adding new bullets to the thing, so let's go ahead and open this up and we'll add a public void, I don't know, add bullet. Maybe give it an X and a Y coordinate. And then this will handle actually adding it to the screen. At the moment, let's just say add object. We'll say a new bullet, X and Y. We don't actually have to store anything that's added to the world as a member, but I like to in these cases because then I can reference them from the world's act method or setup and whatever. So let's say the player shoot needs to call world add bullet. Now this is a my world class, it's not the base world. There is a method called get world, but we can't call it from there because our add bullet is not a part of the world. So we have to say my world is a, cast it to a my world, get world. Then we can say world dot add bullet, and we'll just pass in this character's X and Y coordinate. So let's see, it adds a bullet right where I am, and we can add infinite bullets. So we'll also probably need a cooldown, but for now let's just add some behavior to the bullet. So let's say public bullet, it should move pretty quickly. So let's say speed is 10, and the behavior of the bullet is basically just going to be moving up constantly until it hits something. So okay, so that works. And then it hits the edge and it should just be destroyed. So if is at edge, which really it can only hit the top edge because it only moves upwards. If it's at the edge, we need to remove it from the world. So get world dot remove object this, and we need to return to make sure nothing else gets executed afterwards. Otherwise there could be some errors. Okay, so these bullets are getting removed. So next we need to check it to see if there's a collision. Public, let's just say void handle collision. So this will handle any collisions with these guys. Well, let's say Boolean. I'm just trying to think because we have to make sure to return from these methods. Otherwise there could be just a problem with like a reference error somewhere. Okay, Bool will handle collision with Greenfoot. It will do collision for us. We can just say we're only concerned with colliding with invaders. So invader collided is we have to cast it to invader, and it'll give us get one intersecting object method, and we'll pass in the invader.class. So that will either return null or whatever the bullet is hitting. So if collided is not null, then we will want the world to remove this enemy. So the world should probably handle that in its own method. So let's say public void remove enemy, because then we can increment a score and whatever. We'll just pass in an invader, and it will be responsible for remove object, the invader. So we'll add a score in a little bit, but for now, we'll just say we have to do the same thing with, oh, where did we put it? This get world thingy world dot remove enemy, and we'll pass in the collided object. If that is true, we're going to return true because there's a collision. Otherwise, we're going to return false because there was no collision. If there was a collision, else if handle collision ended up true, we again want to remove this stuff in return. So let's, instead of making this else if, just say or. The bullet will be destroyed if it hits an enemy or if it hits the edge of the screen. And then it returns. So let's see if this works. Okay, so that works, and at the moment it's a little bit too easy because I can just shoot all day. So let's add a cooldown. We have our player. Let's do something like private integer m bullet cooldown. and we'll just initialize it at 0 so you can start shooting immediately. Check input. If space is hit and the cooldown is 0, then we can shoot. Otherwise, don't let the player shoot. So if we're shooting, let's set the cooldown to 100 to begin with, and we can kind of adjust the numbers later. And then finally, in act, we want to make sure we decrement the cooldown. Otherwise, we can only shoot 1 bullet. So if cooldown is greater than 0, we're just going to subtract 1 from it every time. So can run this. Okay, so the cooldown is a little bit too long. Let's go ahead and just do show text what the cooldown is, so you can kind of get a visualization for what's going on. So if I run this, I have to say get world, it's a method of the world. So you can see that the cooldown goes down, and then I can shoot again once it's at 0. So that's a little bit long. Maybe we'll make that 20. And I have not prepared any sound effects. We could just use BFXR because it sounds retro, and that's what a lot of people use, even though I kind of prefer not to do it because a lot of people use it. So this is still a little bit easy, but we can go with it for now. While we're at it, let's just go ahead and go to bfxr.net. We can generate some sort of sound effect. It's so loud. I guess that works. Okay. And instead of the images folder, we'll throw it in the sounds folder. Laser.wave. And not 100% sure what the sound effect is. I might have to look it up on Greenfoot's thing, because I don't remember. Greenfoot, play sound. Sound. Okay, it's just greenfoot.play sound and then the name of the sound. And did I name it uppercase or lowercase? I did uppercase. So laser, let's make sure that works. Yeah, so now I can put sounds in the game, yay! Okay. Reset. Let's see, we need to add a score. So let's go ahead and go into the world. We'll just create a private int m score. We'll set it to 0. And we will need to add an act method for the world. It doesn't auto-generate it for us for some reason, but the world does have an act method as well. You can say show text, score, and the score value. Let's see what 10 and get height minus 20 looks like. So that's going to be off the screen. So let's try 100. That's a little bit too far that way. Maybe 80. Okay, maybe 50. Not 550. Okay, so that's a good location. It will probably go off the side of the screen if we get to like a 10 or 20 or something, so let's do 60. So we have a score. If we remove an enemy, let's add 10 points to the score. So yay! And since we're doing sound effects, let's also make something for the enemies to blow up. So we'll save this as explosion, and where's my sound thingy? There it is. If the enemy is removed, we'll just play the explosion sound. So run. And so on. So yay! Okay. Now we can either just add another state to the game by just adding a new world if, you know, the enemy count becomes 0, or we could just show some text on the screen. I think that I'm just going to make a little like you win screen or you lose screen in GIMP, and we'll just display whichever happens. So we'll say you win, and gotta find some better font. I don't know. It's a pixely game, so we'll just say you win with pixels, and then that exclamation point doesn't work so good. So let's try a different pixely font. I think press start player 2 or something. Press start 2p. You win. Yay. Okay, so we can save this as... What's that offset? Weird. Okay. We'll just save this as you win. And you lose. We'll set this to red color. Maybe lighter. And we'll say you lose. Okay. So, let's go ahead and just create another world. We'll just say ending world or something. And we'll say end world. And in the constructor here we can change this around so it'll be either boolean u1. That way we can kind of figure out how we want to display the message to the user. Did they win or not? So if you won, else, and let's see if we can use just set image with the world. Probably, but I'm not totally sure. So uwin.ping. Okay, did not like that. Even though the world itself has an image, what does it have instead? Set background, I guess. Set background. So when that happens, let's go ahead and go to my world. It will, let's see, if an invader gets below some point, then it loses. The player loses. Otherwise, if the player has killed everything, they win. So let's say public void go to you win. Public void go to you lose. That was not there. Okay. So we can say, let's see, how do we do this? End world, next state is a new end world, and we're going to pass it in true because you win. And then Greenfoot dot set world. So let's see. One of the problems, I guess, with Greenfoot is that it doesn't have any sort of IntelliSense type of thing or autocomplete. But at the same time, maybe it was done that way on purpose so students would learn. So in world next state, you lose. This will be false. Okay, so let's check. In act, we can get the amount of invaders left on the screen. I don't remember how. Let's check this out again. Google or DuckDuckGo or whatever. Greenfoot get count of actors or something. And, oh no. Get total number of objects. Get world number. No, that's not what I want. Maybe it's just one of the world methods. Get number of objects, but that's all objects. I want a specific. Okay, well, we can get a list of objects and get the size from that. So int invader count is get objects of the invader class dot. Now it's not going to be length like an array, but okay. Length dot count dot size. That's not right. Dot size. Is that it? Okay. Size. I always love these inconsistencies, don't you? Okay. So invader count. If invader count is 0, then you win. Go to you win. Now run, and I'm gonna mute that because it's a little annoying. Let's go ahead and just kill all of these and make sure it goes to the other state. Yay! Okay, reset. Finally, the way we can tell if the enemy has won or you have lost is if any of the enemies happen to get down to, I don't know, maybe where the player's Y is, or we could check to see if an enemy collides with the player. That would work. So just like we have bullet colliding with an enemy, we can do the same sort of thing with the world. So let's go to Invaders Act, public void check collision with player. Paste in this stuff, check collision with player. And here we'll have the player object instead. If, okay, player.class player, here. So if there is a collision, instead of calling remove enemy, let's say world.goToUlose. So if the enemies get so close, and we can speed this up like this, then that will set it as you lose. So is it a complete game? Well, it doesn't have multiple levels, but it's a start for your Space Invaders clone. It's a little bit easy, but that'll work. And one of the cool things with Greenfoot is we can hit share. They have like a hosting site, but I've had a little trouble with exporting as a Java applet for web. I guess you can do it, but I don't remember what the problem was. Like, it wasn't working in some browsers or something, but you can also extract it as a nice application. I'll go ahead and do this for the moment. We're not going to commit it to the GitHub, but let me go back to this folder. Did it put it out here? I didn't pay attention. Okay, here it is. And let's see, open it with, set the executable bit, allow executing as a program. Let's open it, and it comes over here. And then if the player, you can distribute it pretty easily, as long as the person has Java installed on their computer. You can play it on any platform, and then they can reset and run the game. So it's kind of cute. It's kind of nice if you just want to make a simple game or a prototype and share it. Let's go ahead and say that we're done with this. The note I had earlier was to add the score. We're going to go ahead and quit. Let's go ahead and check this out. Git add, and I'm going to do a dry run because I want to make sure I don't need to add all those documents. So let's go ahead and say nano.getIgnore. So it has some Java stuff that we want to ignore, but over here we have, like, I don't know if Greenfoot uses this, but we probably don't need the docs. So let's get rid of that whole thing. We probably don't need the ctext. What else do we have? Yeah, that will be ignored. So I'll save my git ignore. We'll do another dry run. We have a lot less stuff this time. Again, I don't know if we need the sound index, but we'll... Oh, wait. No, I don't want you to add docs. Okay. Can we do this? I'm not super up on my... regex. Greenfoot. Let's see if that does it. No, don't add the documents. It's annoying. Okay. Obviously I'm doing something wrong. Let's just say git add all the Java files, git add all the wave files, git add, and we can just do this as well. Git status, git add the git ignore, and we have a background, git add.jpg. Let's also go ahead and add the Greenfoot project. That readme is just going to be, it's an auto-generated thing, so git status. Let's go ahead and commit this. I wonder if that sound index is openable. Okay, let's just add that. Okay, so Space Invaders, no, it's not Space Invaders, it's Moose Invaders. Not a copyrighted thing. 1.0, and we'll go ahead and push that. So, if you're interested in working with this further, maybe adding more features like other Moose Invaders, adding different levels and so on, you can come to this Classic Clones page, go to the Moose Invaders. If you have a Greenfoot account, or sorry, a GitHub account, You can make a fork. It'll make your own version of the repository. It won't overwrite mine. Or you can clone it to your hard drive without having a GitHub account. Or you can download a zip if you don't want to install Git, and all of that. So if you make any changes, what you should do is, let's see, I'll just create a fork really quick so I can show you. Let's make a fork on my account. We'll go to, it's going to show here, forked from the classic clones, but this is my version. I could pull it down to my computer. I would just use this clone link. And then once I was done, so I'm just going to add a really, really simple update. So this is an example of doing a pull request. We will commit changes. So now I've made changes that aren't active on the classic clones. We can say back on classic clones, let me see if I can remember this right. Pull request. Do I just say create a pull request from classic clones? Okay, let me see really quick. I don't remember exactly if I have to. Okay, from my repository, I can say create a pull request. It's going to say here's the base fork, here's the head fork. At able to merge, it'll auto merge it for us, and I can create a pull request. I'll just, let me see, is there a message? Update. Pull this fork to get an updated README. Create pull request. So then from the classic clones here, if you look at the pull requests, anyone can put a pull request in, and anyone can choose, okay, I'm going to clone the base repository and this feature or that feature. Or alternatively, if you have a feature that's really nice and implemented well and improves the game, I could go in here, look at your merge, and I could merge it into the core repository. So we merge this, and we go back to this code, and here's the change that I made. So if anyone's interested, go ahead and make a fork of this code, add some features, make a pull request, and either it'll get added to the base repository, or at least there will be multiple pull requests of expanded versions of this game. So finally, let me get out my project notebook. My idea for classic clones was to basically make clones of old arcade and Atari style games, just to kind of give an example of different languages and libraries. So I have a whole list of these. One arcade game I really like is Venture. I have a copy of it for the Commodore, no, not the Commodore, ColecoVision. And so that might be something I clone in the future. Breakout is a pretty easy game to clone. And then as far as tools, we could have something like JavaScript game, or using C++, or using Gaderos, or Pygame, or just different stuff like that. So if you have any suggestions for games to be cloned, or tools that you would like to see, let me know, and maybe we'll make some clones together. Okay, that's pretty much all I have for now. Thanks for watching, and happy programming!